खुद ब खुद हो जाएगा, एक बटन दबा। Assalamualaikum everyone. We are starting with this chapter that is P3, and we are focusing on differential equations. So let me just get everything ready. Yes, the camera and everything. So I mean, it's a kind of a technical thing that you get started with this. So let me just close the voice from here, and I hope you all are doing good. So now, what is the objective today? The objective today, I hope the voice is all good, all clear. Let me just double check. Yes, the camera is on, the audio is on. So the objective for today is that in 2019, every single year, there are 5 variants of P3 if I exclude the February-March paper. 3 of June and 2 of November. So my focus is to focus on those particular 5 questions. So the first question is right in front of you. I don't want the tea to get cold, so let me just take a few sips. Till that time, you can just have a look at the first question. It's 8:28. So I'll also time ourselves that how much time is being taken. So let's get started with this. It's 8:28 p.m. and we are starting. The first part is differentiate 1 over sine square theta with respect to theta. So let me write d by d theta. And let me write this thing that this is sine theta raised to power of -2. Now what is the background logic over here? That sine square theta means sine theta, the whole thing square. So if it's 1 over this, when I take it up, it has a negative index, negative power. That's the first thing. Now the rule that's applicable over here, that is the chain rule, that is -2 comes down and sine theta remains as it is. And power reduces by 1 into derivative of bracket, derivative of sine is cosine theta. So that is the first thing. This is -2 sine cube theta, and this is cosine theta, and that is the answer for this particular part. All good, all clear? Just 2 marks, something very, very basic. It's an application of chain rule. Now the next part, and we are focusing on differential equation. Just have a good look at it. And let me get my things straightened out. Okay. So now the question says the variables x and theta satisfy this differential equation. So this is x and theta. These two are the variable. There is a differential equation. X tangent theta dx by d theta cosec square theta is 0. Where theta lies between 0 and pi by 2, x is positive, and this is the condition. It is given that x is 4 when theta is pi by 6. Solve the differential equation, obtaining an expression for x in terms of theta. So these are the few things that we need to do. Now, first of all, when you are solving this thing, you have a lot of space. So that's the first thing that I want to have a look. The next thing that I want you to do is to start from the extreme left. Yes, use the dotted lines, but start from this place. So the first thing, copy the question as it is. That is x tangent theta dx by d theta, and take the cosec square theta to the other side, that is negative cosec square theta. So I hope the first step is all good, all clear. Now we all know that the concept, the underlying technique is that we separate the variables. And originally it was called variable separable. That means separating the variables. Now we have theta over here, we have theta over here, we have theta over here. So the first step is negative cosec square theta d theta divided by tangent theta, this is equal to x dx. That is the first thing. The next thing, I'll go very, very slow on this because this is a chapter that involves differentiation, integration, differential equation itself. And keep in mind one thing, that when we talk about differentiation, when we talk about integration, when we talk about differential equation, these three are like 1/3 of the syllabus, literally. That means the marks are around like 25, 26 marks out of 75 that is used for this. So be very, very careful with this. The next thing that I want to do is that, let me simplify this. Minus cosec square, that is minus 1 over sine square theta. And division by tan theta is multiplication by cosine theta over sine theta. I hope it's very clear to everyone. Tangent is sine over cos. 1 over tan is cos over sine. Now this is negative cosine theta and this is sine cube theta. Now have you seen this thing someplace else? I think so, you have seen it. And where exactly have you seen it? You have seen it upstairs. That is over here. This is sine cube theta, this is cosine theta, this is negative. All good? Now what exactly I'm going to do with this one? Integral of negative to cosine theta. Let me write the negative with it. Negative cosine theta over sine cube theta d theta should be what? Should be this thing, 1 over sine square theta. Because integration and differentiation are reversible process. When you differentiate something, you get this. When you integrate something, you should get back this. Now, what do we have over here? We have this thing simplified, negative cos theta, sine cube theta. Let me write this thing first. Negative cos theta, sine cube theta, d theta. And integration sine, let me put it over here. Integration sine x dx, let me put it over here. Now the integral of this thing, now let me shade this a little bit thicker. So now the integration of negative cos theta sine cube theta should be, this 2 will be taken down. So that is too thick for this. This 2 will be taken down. So that is 1 over 2 sine square theta. So therefore x dx, and let me integrate it. Yes, this is x square over 2. This is how much? This is 1 over 2 sine square theta. This is 1 over 2. And this is sine square theta. That's in the denominator. Plus a constant of integration c. Again, I would like you to take a good look at it. It's not just that my tea is getting cold. That's why I'm deliberately asking you. That is one of the reasons, but I want you to have a good look at it. Now the next thing, let me multiply by 2. If I multiply by 2, x square, this is 1 over sine square theta, and this is 2c. And let me write 2c, let 2c equals to another constant d. I hope you have no trouble with that. This thing is done. Now it's asking the condition x is 4 when theta is pi by 6. X is 4 when theta is pi by 6. So therefore, this is 4, this is square, this is 1 over sine of pi by 6 whole square plus c. This is 16, this is 1 over sine of pi by 6 is half, square plus c. 16 is 1 over 1/4 plus c. 16 is equals to 4 plus c. Therefore, c comes out to be 12. Now, I'm using all the possible space that there is. Now, once this is done, so instead of c, actually this is a d. Let me correct myself. So let me write a d over here because I've already changed c with d. So therefore, this is d, this is d. So now this is the equation. X square is 1 over sine square plus d. X square is 1 over sine square theta plus 12. And they are asking us express x in terms of theta. So therefore x is equals to square root 1 over sine square theta plus 12. That's one way of writing down the answer. Also, if someone wants to write x is equals to cosec square theta plus 12 square root, that is also the answer. So that is how the first question is done. And let me just show you the mark scheme. I should have added it as a thing. So that is question number 6. It would be the other way around. There it is. Question number 6. Question number 5. So that is the answer. I hope you can see it. And it's just have to tell the phone. That is x is equals to cosec square theta plus 12, the whole thing, square root. So this thing is done. Let's move on. The next question. So now the next question is right over here. And just have a good look at it. This is one single question, no parts. And this is for 7 marks. I'll just check one thing, that this is all good, all clear. Okay, now we are all ready to get started. I think that question hardly took 10 minutes. Now we are starting at 8:38 and let's just continue the journey. Now the question says the variables x and y satisfy the differential equation. That's given over here. It is given that y is 0 when x is 0. Solve the differential equation. And no, there is this first part and there is also a second part. Obtaining y in terms of x, a lot of space. And then at the end, explain why x can only take values that are less than 1. That's a very, very good question. Only for 1 mark, but it's definitely worth it. So now the first thing, again, get started with this. dy by dx is equals to x e raised to power of x e raised to power of y. We know that a raised to power of m plus n, that is a power m into a power n. That's how we break it up. 1 over e raised to power of y dy, that is x e x dx. Simplify it even more. E raised to power of negative y dy, that is x e x dx. Integrate, integrate. Now, first of all, if I look over here, x e x dx, what is that? Let me do this thing on the sidelines. That is integration by parts. So this is integration by parts. U is x, dv is ex dx, du is 1 dx, v is ex. Follow the arrows. That is x ex minus ex integral dx. That is x ex minus ex. And I'm just leaving the constant of integration on the sidelines. So this is x ex minus ex plus a constant of integration c. That's the overall constant. And on the left hand side, this is 1 over negative 1 e raised to power of negative y. Now the rule is, since we'll be making y the subject, it's better. It's not a must, it's just better that we have the constant of integration on the other side. Now let's multiply with a negative 1. So when I multiply with a negative 1, e raised to power of negative y, this becomes positive, this becomes negative, and plus c can be written as negative c. So let me write, let d equals to negative c. Doesn't make a difference. I just want things to be simplified. Now what I can do is that I can work out the working for this one. And let me evaluate the constant first. There are two options for this. Either I evaluate the constant or I can evaluate the, make the subject again. I think it's a good idea that we can go ahead and evaluate the constant. X is 0, y is 0. So now over here, let me write over here. y is 0 when x is 0. E raised to power of minus 0, e raised to power of 0 minus 0, e raised to power of 0 plus d. E raised to power of 0 is 1, e raised to power of 0 is 1. This becomes 0, 1 on the left, 1 on the right. Therefore, d comes out to be 0. That is the first thing that needs to be done. So now, once this is done, rewrite the equation. Rewrite the general solution, and it will now become the particular solution. So now we will write e raised to power of negative y, e raised to power of x minus x, e raised to power of x. So far so good. So rewrite the particular solution. Actually, the general solution becomes the particular solution because we have found the value of the constant, which comes out to be 0. Now what we can do is that we can take ln of both sides. So even before that, let me write ex common, and this is 1 minus x. This is e raised to power of negative y. And let me write over here, take natural log of both sides. So therefore, ln e raised to power of negative y. This is ln, the whole thing, e raised to power of x, 1 minus x. So this is minus y, ln e, let it remain as it is, ln e raised to power of x, 1 minus x, bracket closed. Ln of e is 1. Therefore, y is equals to minus ln e raised to power of x, 1 minus x, and therefore I can take this minus and I can make it the power. Which rule am I applying? I'm applying this rule. Log x power m base a can be written as both ways, m log x base a. So basically I have raised it to a power, therefore y is equals to ln 1 over e raised to power of x, 1 minus x, bracket closed, like this. So that is the subject of the equation. What else are they asking? Obtaining y in terms of x. So the 7 marks are obtained over here. Now it says explain why x can only take values that are less than 1. Now focus on this. ln, let me focus on this thing. Let me draw a box over here. This is ln, this is e, x 1 minus x. Now we know that natural log exists for positive values only. Now, if it exists for positive values, it is necessary that 1 minus x should also be positive. Therefore, minus x should be positive. Therefore, minus x is greater than minus 1. Therefore, x is lesser than 1. That is why x can only take values that are less than 1. That is the answer for this particular part, which is part number 2. So I've written part number 2 over here. That is the answer for this particular part. All good, all clear? Now just acknowledge it on the WhatsApp group that you're part of, or just acknowledge it on this comment section. So the 2 questions are done. So we have done 2 questions and both questions are done and dusted. That's the thing. Just open up the video. So just check as everything is going okay. Yeah. Now let me move to the next page. That is this question number 3. Now question number 3, it's a May-June question and it's variant 33. There are no parts. This is only 7 mark. Let me double check. Yes, they have given you 2 full pages for this. Have a good look at this question and then I'll proceed with this one. So I'm just opening up the fan. Okay. Okay, let's get started with this. The variables x and y satisfy the differential equation. And let me write it down. Variable separable. It is given that this is the differential equation. No, not that thick. Solve the differential equation. This is the condition obtaining an expression for y square in terms of x. Now, first of all, x plus 1 should be taken to the other side. So y dy, and this is y squared over 5. So let me just create more space. Y over y square plus 5 dy. This equals to 1 over x plus 1, and this is dx. So let me just double check. So over here, this is x plus 1. This goes with dx. This is x plus 1 goes down, dx goes up. And then we have dy, we have y, we have y squared plus 5. So this is y, this is dy, this is y squared plus 5. All good, all clear. Now, the background knowledge that I need is this. The first thing is over here. The second thing is over here. The first thing, that is if the numerator is the derivative of denominator, then the integral is ln of denominator. It's better that we write a modulus sign. If it's applicable, we will use it. Similarly, 1 over ax plus b. If the chain rule fails, then ln comes to the rescue. And let me just correct it. The b looks bad. Ax plus b dx. Chain rule doesn't work. So this is 1 over a. That is ln ax plus b plus c. So now over here, what is missing? A 2 is missing. Balance it out with a half. Because when you multiply and divide by a constant, this is only applicable for a constant only. So this thing follows this rule. So therefore, this is what? This is half ln y square plus 5. Over here, this follows this rule. The coefficient of x is 1. So this is 1 over 1 ln x plus 1. And now it's a good idea that when everything is coming in terms of ln, it's better that we write the constant of integration also in terms of ln. So that is the thing that is much needed. All good, all clear? So now we have to apply the rule of log. What is the rule of log that I need to apply? Hold for a second. Let me just draw this. The rule says that the log xy base a can be written as log x base a plus log y base a. That is one rule. There is also another rule that I need to apply. That is log x power m base a, that is m log x base a, and it was applied in just few questions before. So over here, this half will become the power, and this thing over here will be used, simplified using this. So let me simplify this. This is ln square root y square plus 5, put a bracket. This is ln a into x plus 1, close the bracket. Now the last thing that is needed over here is this. No, that's bad. That is this. Log m base a, if it equals to log n base a, then m should equal to n. So this is like one thing. This and this should be equal. So square root y square plus 5 is a times x plus 1. So this is the general solution so far. Now I need to plug in the condition y is 2 when x is 0. Y is 2 when x is 0. So 2 square plus 5 square root, that is a times 0 plus 1. So this is square root of 9 is 3 is a times 1. Therefore, a comes out to be 3. anything else except that we have to obtain an expression. So now back to the black marker, y square plus 5 square root, that is 3 times x plus 1. Y square plus 5 is 3 times x plus 1, the whole thing square. That is 9x plus 1 whole thing square, that is y square plus 5. Make y square the subject, that is 9x plus 1 whole square minus 5. And that is the answer for this particular part. So that is what they are asking for y square in terms of x. So that is the third question that is done and dusted. Let's go to the fourth question, and now it's the November series. A different kind of a question, an insect exponential type of question. So we came across some log questions. Now it's the exponential type. So I'm just checking if there is any question. So someone already wrote clear. Thank you for the response. Let's move on. Now it says, let me just check if I just had a class before. So I just want to check. Yes, it's all good. Now it says the number of insects in a population. So this is the number of insects in a population T weeks after the start of observation is denoted by N. The population is decreasing at a rate proportional to this. The variables N and T are treated as continuous. There is no breakage. Just use it. Don't overthink. T is 0, N is 1000, dN by dt is negative 10. Part 1, show that N and T satisfy this differential equation. The first part is differential equation. Second part, solve the differential equation. Find the value of T when N is 800. So they are not asking us to make N the subject, maybe in the third part. Okay, so let's get started with this. dN by dt, it's a decreasing rate. It's proportional to N e negative 0.02t. Negative dN by dt is equals to k n e raised to power of 0.02t. So far so good. Take this negative to the other side, or even before that, just plug in this condition. When t is 0, n is 1000, dN by dt is negative 10. Negative 10, that is k, n is 1000, e raised to power of negative 0.02. And what's the value of t? The value of t is 0. So basically, you have plugged in three things. Let me highlight it. t is 0, that's right over here. N is 1000, that's right over here. dN by dt is negative 10, that's right over here. So now simplify, negative negative cancel. This is 10 over 1000. That is equals to k, e raised to power of 0 is 1. Constant raised to power of 0 is 1. Variable raised to power of 0 is 1. Therefore, k comes out to be 1 over 100 or 0.01. So let me just use this. Remove this over here. Therefore, negative dN by dt, don't forget that there is a negative sign. I'll be taking it to the other side. Therefore, dN by dt is negative 0.01 n e raised to power of negative 0.02t. All good, all clear. Double check. This is negative, this is 0.01, this is n is right over here. I wrote it before, and this is e. Solve the differential equation. Now, in order to solve it, I'll write 1 over n dn. So I'm taking this n and dn together, variable separable. And this is negative 0.01 e negative 0.02t dt. So always be very, very vigilant when you're copying it down. It's time to integrate. So we just came across the concept of ln. So this is 1 over 1 ln of n. This is exponential. So let me write it over here. Integral of e raised to power of ax plus b dx, that is 1 over a e raised to power of ax plus b plus c. So this is negative 0.01 divided by derivative of the bracket, that is negative 0.02, and this is e raised to power of negative 0.02t plus a constant of integration c. So first of all, this negative cancels out. This comes out to be half. This is e raised to power of negative 0.02t plus a constant of integration c, and this is ln n. Now there are two possibilities. The two possibilities are either I evaluate the c at this point or I make the subject and then evaluate it. That's entirely up to me. What do you people think? I think it's a good idea. Just plug in t is 0, n is 1000. So let's plug in t is 0, n is 1000, ln of 1000, this is half, e raised to power of 0, this whole thing becomes 0 plus c. Now e raised to power of 0 is 1. So ln 1000 minus half is equals to c. So this is what we are getting. That means this equation is ln n, no, not this thing. This is ln of n, that is half e raised to power of negative 0.02t plus ln of 1000 minus half. This whole thing is c. So let me highlight this thing in blue. This whole thing is c. So let me just remove this thing and let me highlight it. This is c. That is written over there. And now they are asking, find the value of t when n is 800. So if I plug it in and let me write n is 800, find t. So ln of 800, that is half e raised to power of negative 0.02t plus ln of 1000 minus half. Ln of 800 minus ln of 1000 plus half is equals to half e raised to power of negative 0.02t. ln, you can just use a calculator or simplify it further, that's your choice. Ln 100 over 1000 plus half multiplied by 2 is e raised to power of negative 0.02t. So now this calculation, I just did it before so that life becomes easier for me and for you. So therefore this value is coming out to be, after the division, this is 0.5537. This is 0.5537. This is e raised to power of negative 0.02t. Now take ln of both sides. Take ln of both sides. When I take ln of both sides, ln of 0.5537 is equals to ln of negative e raised to power of negative 0.02t. That is negative 0.02t ln e. We know that ln of e is 1. Therefore, t is 1 over negative 0.02. And this is ln of 0.5537. And this answer is coming out to be how much? T is coming out to be 29.56. Therefore, T comes out to be 29.6. Was any unit mentioned? I think it was weeks. Yeah, it is weeks. So T comes out to be 29.6 weeks. And this is given correct to 3 significant figure. This was 4SF. This is final answer. That is given to 3 significant figures. This thing is done. Now the last part. What happens to the value of n as t becomes very large? Now sometimes they ask a difficult part only for 1 mark because they know that not everyone has the privilege of being taught well, or not everyone has the capacity to do it very, very correctly in the exam mode. So let's go very, very easy on this. I think I'll pick up the thing from here. That's right over here. So let me just highlight this. There is ln n. Let me choose another color. So that's ln n. That is half e something. And this thing is there. So let me start picking up things from here. So let me write over here. That is ln n. And this positive ln 1000, take it the other way. ln of 1000. And then I see a half over here, I see a half over here. So half common. And this is e raised to power of, inside the bracket, e raised to power of negative 0.02t minus 1. This is ln n over 1000. This is multiplying by 2, that could be done. Or this is, we can leave it as it is also. So now what we can do is that we have this thing if t becomes very large. So this is half e raised to power of negative 0.02t minus 1. What I can do is that n over 1000, this is e raised to power of this whole thing. So there are two approaches to this. Now, which way do we want to go? If t becomes very large, so therefore, I'm just thinking, should I make n the subject or I can do it later? Let me first simplify this side. So let me write it over here, ln, and this is n over 1000. And if I make half 1 over e raised to power of 0.02t minus 1. So it's not worth making this the subject. So I've written one more step. Now t becomes very, very large. That means infinity. So e raised to power of 0.02 infinity would still be very, very, very large. It will still be infinity. But we know that I just need a little bit more space. 1 over infinity becomes 0. A constant, a value divided by a very big number becomes 0. That means, what am I left with? So let me highlight that. I have this half. I have this negative 1. So basically, I'm left with this, which is ln n over 1000. So that is what I was deliberating on. Is it worthwhile making it the subject, or first simplify and then make the subject? So I think I'll write down first simplify and then make the subject. So yes, this is a crucial decision that you need to take. This is equals to half bracket 0 minus 1, which is negative half. N over 1000. That is e raised to power of negative half. N over 1000, that is 1 over e raised to power of half. That is 1 over square root of e, that is n over 1000. So therefore, n is 1000 divided by square root of e, and that is the answer for this particular part. Now, I have used a lot of space in this particular question. I wrote it out very, very wide. I think this was the most elaborate question. 1 mark, 6 marks, 7, 7 plus 1, 8 marks. Now, there were other questions of 8 marks also, or 9 marks also, but they were not as elaborate as this. So now one thing that I should be careful is that my spacing. So I should push things to the side. If there is a need, I should draw a line and then work it out. So maybe this much was the overlap, but this could easily be accommodated over here if I would have written a little bit thinner. So always be careful with the space. And we are on the last question. That is for 8 marks and 2 pages are given. Now this is October-November 2019, variant 32. Now the question is, let me highlight it. The variables x and theta satisfy the differential equation sine half theta. dx by d theta is cos half theta. And we also have this thing which is dx, we have x plus 2. And let me just change the color. And we have the red color. That is this theta thing, this theta thing, this theta thing. So now let me write 1 over x plus 2. 1 over x plus 2 dx integration. And this equals to cos half theta divided by, let me just write it better, cos half theta divided by sine half theta, which becomes cot, but you don't make it cot. Cot is broken down into sine and cos. Now the rule is the same as before. If the numerator is the derivative of denominator, then the integral is ln of denominator. And the other rule is 1 over ax plus b dx, that is 1 over a ln ax plus b plus c. So now we apply this sign, the modulus sign. When there is a need, as such we can just use a bracket. So over here the coefficient of x is 1, sine half theta, the derivative is half cosine theta. So let me write half over here. Let me push this thing a little bit to the side. In order to balance it, division by half is multiplication by 2. So I have written a 2 on the outside. All good? So now I'm applying the concept. This is 1 over 1 ln x plus 2. This is equal to ln sine half theta. And since everything is in terms of ln, so let me write ln a over here. Now, using the rule of log, which was given before, let me make this the head of this thing. Or I can first evaluate and then I can make the subject. That's my choice. So let me just put in the condition first. That is, it is given that x is 1 when theta is pi by 3. Solve the equation, obtain an expression for x in terms of cosine theta. Now this is kind of tricky at this point. Why cosine theta? Why not half sine theta? Why cosine theta? Why not half cosine half theta? That is the main thing. Now let me just apply this condition. The condition is when x is 1, theta is pi by 3. And therefore, half theta will be half of pi by 3, which is pi by 6. Keep that in mind. And also know that sine of pi by 6 is half. So I'll be using this. So now apply the condition. This is ln 1 plus 2, which is 3. This is 2 ln sine of half theta is half. So 2 ln half plus ln of a. ln 3. Make this the power, that is ln of half square plus ln of a. Simplify using log, ln a into 1/4. Plus means multiplication, and this thing over here, this is 1/4. This is ln of 3. Now I can comfortably say that ln of 3 equals to a into 1/4. In other words, a is equals to 4 into 3, which comes out to be 12. So the value of a is 12. All good, all clear? Let me rewrite it again. ln x plus 2 is equals to 2 ln sine of half theta. And this is ln of 12. The value of a is 12. It's written as ln of a. So therefore, this is ln of 12. That is the particular solution. Obtain an expression for x in terms of cos theta. Now comes the real part. If I make this the rule according to the rules that was given over there, log x power m base a, that is m log x base a. So therefore, let me simplify this. This is ln x plus 2. This is ln sine half theta, the whole thing square plus ln of 12. That thing is all good, all clear? Now we know that sine theta, the whole thing square, can be written as sine square theta. Sine half theta, the whole thing square, can be written as sine square half theta. Now, what is the relation? We know that cos 2a is 1 minus 2 sine square a. Or sine square a, if I make the subject, that's half of 1 minus cos 2a. Now focus on this. This is a, this is 2a. If this is sine square half a, this would be half 1 minus cosine a. Why? because the ratio of A to 2A is 1:2. This is 1, this is 2. Rewrite it again. Sine square half theta can be written as half 1 minus cosine theta. So therefore, this is ln bracket. This is half 1 minus cosine theta. Half 1 minus cosine theta, bracket closed, and rest of the thing I'm writing in black pen. This is ln x plus 2. So this was the working that is outlined over here using double angle. All this thing, all this energy, this was applied in that double angle thing. You can do it on the sidelines and then insert the result over here. Now, since there is a positive sign between the two, that is multiplication. So I'll write ln, and this is half into 1 minus cosine theta, the whole thing into 12, close the bracket. And what does it become? This is ln bracket 6 1 minus cosine theta. 12 and 2 cancels out. This is ln x plus 2. Now, if you are taking ln of two numbers, ln of something, not numbers like expression, ln of this thing, in other words, this equals to this. So therefore, x plus 2 equals to 6 minus 6 cosine theta. Don't forget the 6. And we are supposed to make x the subject in terms of cosine theta. So x is equals to 6 minus 6 cosine theta minus 2. X is equals to 4 minus 6 cosine theta. And yes, that is the final answer over here. No other parts were asked. So that is 5 questions. We started at, I think, 8:28. So we started at 8:28. We finished at 9:13. And that is how much? That is like 34 minutes and 13 minutes, 34, 37, 47. So 47 minutes to do 5 questions of 2019. And I think that's a pretty good way. That's a pretty good speed that you can also achieve. So that's all for today. Stay tuned for more content on mathematics with Shahab Yaqub. Do let me know how you feel about this particular video. Take care, everyone.